Hello, this is the last section of Chapter 5 in College Algebra. So we're doing that grand finale where we use our graphing calculators to help us find the zeros for these crazy polynomials here. So remember that we learned that the highest power tells you how many solutions there will be. So in this one right here, I know I'd have 4 solutions. This one I would have 4. It has nothing to do with the coefficient. 4, 3, 3. So keep that in mind. Now we have the rational root theorem right here that says that we can kind of use our calculator and this theorem to help us spot any the rational roots of a polynomial function. So it says that no matter what, some math nerd of long ago and far away found this pattern of the rational roots of the polynomial, that they always ended up being factors of the last number guy over factors of the front number guy. Now we don't have to use that a whole lot anymore since we do have technology, but it does help us with those occasional fractional roots. So since it's hard to spot on the calculator the difference between 1/3 and 2/5, we can use this rational root theorem to see what kind of fractions we might want to check. So if I took the factors of the last number guy, 6, those factors would be 1, 2, 3, and 6. Those are the only numbers that would multiply to a 6. Now all of these could be positive or negative. So if you were asked to list all of the possible rational roots, you would have 1, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, all over the possible factors of -2. So last number guy of 6, and then front number guy of -2. Well, -2, of course, only has factors of 1 and 2. So it would either be all of these numbers over 1 or all of these numbers over 2. Since plus over plus is plus, plus over minus is minus, plus over minus is minus, and minus over minus is plus, basically the bottom line is they always come down to either plus or minus. So I don't have to put the plus and minus in both the top and the bottom. So it was either 1 over 1, or 1 over 2, 2 over 1, or 2 over 2. Hang on, let me write this more organized. Okay, so it was either the 1 over 1, the 1 over 2, the 2 over 1, or the 2 over 2, the 3 over 1, or the 3 over 2, and the 6 over 1, or the 6 over 2. So 6 over 2, of course, would reduce to 3, which we have accounted for right here. 2 over 2 would reduce to 1, which we have accounted for right here. So what they had to do back in the day before the awesome super graphing calculators is they would have to go and test these possible rational roots. So they would use synthetic division, just like we were doing back in section 3, to go through and see if they got that happy face 0. And they were super grateful to this math nerd right here that found this pattern, because before he found that pattern, they had to test every single possible number ever. So every integer, every fraction, until they could spot one of those zeros, one of those rational roots. So this narrowed it down a whole lot. So even though this seems like a lot, it's significantly less than every single number ever, positives and negatives. So of course, that would be infinity numbers to try to check. So they're like, oh, this is awesome. Now there's only like 8 of them. In fact, there's not even 8 because this reduced to that and this reduced to that. So they had much less to try. But we don't even need all of those. This is just going to help us, like I said, spot potential fraction answers. So let's try it one more time with this one. And we're going to reference that for when he's important. So the back number guy is 8. The front number guy is 7. So the factors of 8 would be 1, 2, plus or minus 2, 4, or 8. Fix that. It makes it look like a plus or equals. Okay, and then the only factors of 7 are 1 and 7. So it was either these over 1 or any of these over 7. Okay, so those are all the possible rational roots. So like I said, even though there's 16 of them here, that's still better than trying every possible number ever. So don't worry about it too much yet. Let's use our calculator and you're gonna see when this comes in handy. I will tell you. All right, so this one is exactly the same as a problem in section 3, and it's a whole lot like this last problem we did in section 4 right here. It's kind of a combo. So in section 3, we were asked to find the rational roots by using synthetic division, but we were given one of them, and we put that number in the box, and then we did the synthetic division. So it's the same exact problem, but they didn't give us the number to start. So that's where we use our new graphing skills. So I go type this straight into y equals. So I'm going to type in the 4x cubed minus 12x squared, make sure to use the minus on the side, plus 9x minus 2. When you graph it, it should look like this right here. Kind of cubic squiggle right there. Maybe backwards, but look like that. And then if you have a funny window, do a zoom 6. The bottom line that I want to know on that graph is where did it hit the x-axis? So you can kind of see, let me draw a quick sketch of it back here. If you look really closely, it kind of looks like he might have hit there at 1. And then it kind of looks like he comes up here at 2. Okay, so now we're going to use that magical button trace. That's your best friend for this section. So I'm going to use my trace, and I'm going to see, did he actually cross at 1? So I do a 1, enter. So that says, what is the y value when x is 1? And he is not 0. So notice there, the y value is not 0, it's negative 1. Since he's not 0, it's not hitting the x-axis like I thought he was, that is not one of our happy face zeros. So I say, oh, maybe it was that 2. So I'm going to go trace 2, enter. 2, enter. And there he is. That's our guy. The y is 0. Happy face 0. So since he hit 0, 2 gets to go in the box. And then I do my synthetic division, just like section 3. Always watching out for those placeholders. Remember the rocket. 3, 2, 1, blast off. Okay, hopefully you've gotten really good at the synthetic division. Once you do, it goes really fast. Drop down, multiply, add down, multiply, hang on, negative, add down, multiply, and there's that happy face 0. So you might have seen I almost missed that negative there. If I did, I would have gotten 17. 17 times 2 is definitely not going to make my happy face 0. So it's a good, quick, easy way to check. So that 2 on the calculator and the 2 in synthetic division both told me the same thing. Now to find the rest of the solutions, just like I was saying, most of the time we're going to use quad. Remember, the only time I didn't use quad was when it asked me instead of solutions to factor. So here's my A, B, and C, type it straight in, and you'll see why it didn't hit right there at 1, because the other 2 solutions are the fractions of 1/2. It makes sense that I just get the same answer of 1/2 because it's that double root where it bounces on the x-axis. It goes up, comes back down again. So remember, I had 3 answers. Don't forget that third one that you found on the calculator first. 3 answers, 1, 2, 3. Put all 3 of them. Okay, so this one right here, it's another cube. You could go ahead and graph it in your y equals. Remember, we expect it to be a down up, just like our last one. If you see anything else, go double check you typed it in right. It should look. It goes off the top of the screen there, but I can see that it is a down up. And I can see it hitting the x-axis in 3 places. Let's see if we can spot them. So if you look closely at the notches, it kind of looks like it might be a -2. And it might be a +2, and it might be a +3. Oh, I can do better than that. Okay, so it went way up steep right back there, close to the -2, +2, and then just a little notch right up there at the +3. So let's test those with the trace. So I go trace, -2, enter. Oh, that y value is not 0. Since it's not 0, that's not our guy. That's not our happy face 0. Maybe it was the +2. Nope, not him either. That was a 1. So let's try 3, trace 3, enter. There's our guy. 3 goes in the box. Purple. Okay, my coefficients were 1, -3, -5, and 15. Drop down, multiply, add down, multiply, 0 times 3 is 0, add down, multiply, and there he is. There's our happy face 0. Ding, ding, ding. Okay, so we're on the right track. Everything's working together. So now I'm going to use my quad, that A, B, and C, to get the last 2 answers. Remember that one of them we found at the beginning. Don't forget to include that in your final answer. When you run quad right there, we're going to get a positive and negative square root of 5. So that's why it wasn't quite there on the 2 like we thought. It was actually the irrational number -5. So what I was saying up here by the rational roots, these are not rational, they are irrational. And it was these guys that they struggled with long ago and far away before calculators. So they had to do stuff like this to try to help them work out stuff like this. Okay, but we went through it for a reason. We're going to come back to that. All right, from the beginning, this one's going to have 4 answers. So right away I know. I also see that it's an even power with a positive coefficient, so I should end up with some sort of W shape, and up, up. Okay, so let's graph it out there, type it in carefully. That 9x to the 4th minus 6x cubed minus 5x, oops, I did that. I do this a lot, be careful. See, I forgot to arrow down out of the exponent. It makes it funny, gotta be careful. Start over, 9x to the 4th, arrow down, then minus 6x cubed, minus 5x squared, plus 6x, have to do it again, plus 6x minus 4. So the 2 most common mistakes I see are doing that because it's easy to do, you just forget a little thing, or accidentally using the little negative instead of the negative on the side. So just be careful. When you graph it, you should see that W. If I had accidentally left it up there, you would have seen a much different shape. So here's kind of a weird W. It's definitely an up, up. Okay, so it's almost like a weird looking parabola with this weird squiggle down here. Oops, sorry, I thought I had green. Kind of a weird squiggly shape. Okay. So from there, I see it hitting here and here. Looks like a positive 1 and a negative 1. Well, when I go through these steps of synthetic division and quad can only ever find 2 answers. That's what he does. He works on quadratics, okay? So since quad can only ever find 2, and I knew this needed 4, that means that quad was going to find 2. I needed to find the other 2 with my human eyeballs, okay? Me as a human needs to find 2. So on the graph here, I now need to find 2 of them. Looks like back there at -1, there is a x-intercept. Sure enough, there he is. Trace -1, enter, gave me a 0. It also looks like +1. Let's double check. Trace 1, enter, and there's another one. So there's my 2 that I found as a human. +1 and -1. All right, here's what we do. I just put either one of those in the box. I'm going to start with +1. Coefficients of 9, -6, -5, 6, and -4. I don't have any zeros in there because I have 4, 3, 2, 1, and blast off. Drop down, multiply, add down, multiply, add down, multiply, add down, multiply. There he is. There's my happy face 0. All right, here's what we do when I had to find 2 with my human eyeballs. I keep going. So I add a new box to these new coefficients with the other one, that -1. Okay, so I know at the end of the day here, the end of this problem, 2 of my answers were 1 and -1. So even if you freak out on a test, put these down, you could spot them on the calculator with your eyeballs. So don't miss those points. So from there, we did a little bit of math. We got it down to 4 numbers from 5. I synthetic divide again, ignoring my remainder. So I keep going with just the 4 numbers. Drop down, multiply, add down, multiply, negative times negative is positive, add down, multiply, and there he is again. The last one is my other happy face 0, so we're doing good. And there's my 3 numbers for my quad. Quad can only ever find 3, and quad only works with an ABC, so I had to do it twice. So then my quad would give me the last 2 answers of the weird ones. Positive 1 square root of 3 I over 3 and 1 minus square root of 3 I over 3. And there's my 4 answers. 2 of them were pretty real integer answers, and 2 of them were crazy, imaginary, irrational answers. Technically not irrational, they were just imaginary, but they had irrationals in them. So no matter how crazy the answers get, this will work. This process works every time. Okay, now here is why I was scaring you with all of that possible rational root stuff. So this one right here, I go to my calculator, I start typing it in as the 3x to the 4th plus 11x cubed minus x squared plus 11x minus 4. I type it in, I expect it to be an up, up. And it almost looks like it's not. It's got these crazy steep lines here. I could try to adjust the window to make it look a little bit more normal, but right there, I actually have the information I need. Now remember, this one again was an even. I'd use the blue. Okay, I knew I needed 4 solutions total. Quad only ever gives me 2, no matter what. It only gives me 2 answers. So that means with my human eyeballs, I need to find the other 2 on that graph. I see them there, and the one of them's pretty obvious. It's back there at negatives at 4 or 5. I'm going to use trace to check. Here it was, -4. So I did trace -4, enter, and -4 was one of my answers. He's going to go in that box. He's going to be part of my answer. Okay? Even if you got completely stumped, at least write that part of the answer down. Get that point, okay? The other one is the sneakier one, which is why I showed you all this big messy stuff up here. So you can see that it's not on an integer, it is a fraction. We say, what fraction is it? Is it a half? Is it a fourth? Is it a fifth? Is it 2/5? We don't know. And thus we use that math nerd's work where he got the possible rational roots. So he told us that all of these right here were the factors of front number guy over factors of back number guy over factors of front number guy, which means bottom line, all this mess that no matter what, if we ever got a fraction, that fraction's denominator would always be the factors of front number guy. So that means blah, 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 all this big mess that I just did to kind of show you how much our calculators really help us out, say that the fractions I should be checking are thirds. So I'm going to be checking 1/3, 2/3. Sorry, let me write that better. 1/3, 2/3. Could check 3/3, but hopefully you know that that's really one whole. 4/3, ... If he's over there on the left, I would be checking -1/3, -2/3. -3/3, -4/3, dot, dot, dot. But I would only check thirds because thirds are this front number guy. Okay. So thirds because I misspelled that. That's why I'm a math teacher. Can't spell. Okay, I think it's right. Just my writing's so sloppy. Because the 3 was in the front. Okay. So all of that mess was basically just to tell you that when it's a fraction, check the fractions of thirds. If this was a 5 in front, I would be checking fifths. If this was a 7 in front, like this one, I would be checking sevenths. Okay, you don't even really have to worry about the top stuff. You could limit it down to factors of the top, but if you just start on your calculator and check 1/7, 2/7, 3/7, you know, you're really not going to check that many numbers. And by check, I mean use that trace button. So here we go, we're going to check. If I checked 1 divided by 3 as my x value, so I just did trace 1 divided by 3, enter, there he is. That y value is 0. We found him on our first try. But if it wasn't a 0, I would just keep going. I would do trace 2/3, enter, trace 3/3, enter. And I'd keep going until I found the one that made the y equal 0. And it's never more than, you know, a few of them out there, so it shouldn't take you long. All right, so here we go. Let's finish this up. 3, 11, -1, 11, -4. No zeros because the whole rocket's there. 4, 3, 2, 1, blast off. Drop down, multiply, add down, multiply, add down, multiply, add down, multiply. Happy face 0. Not much closer, we gotta do it again. And this time we're gonna use the fraction of 1/3. One of our answers is the fraction 1/3. Okay. It's not as bad as it seems, because watch this. Drop down, multiply, 3 times 1/3 is 1. Add down is 0. 0 times anything is 0. Add down, multiply, happy face 0. Okay, there's my quad, A, B, and C, to give me the last two answers of plus and minus I. There we go. Last one. This one has 5 answers. I know from the beginning, 5 answers. Sorry. Long day. I'll get it there. Answers. There we go. Okay. So I'm going to start by typing it in the calculator. X to the 5th plus 4x to the 4th minus 26x cubed minus 64x squared plus 185x minus 100. I graph it out. This is odd and positive, so I should see a down, up. Perfect. Okay, now look back here. This one right here is very, very steep. You can see it almost looks like a skinny notch right there. Now, even though I can't see it, basically the calculator ran out of pixels and it was so steep that it doesn't even show up because it's less than a pixel thin. I see that it probably did touch the x-axis. I'm going to show you how to do that. This one obviously touched the x-axis and this one obviously touched the x-axis. This one is a double root because it bounced. This one is a single root because it crossed through. So this one looks like he's back here at positive 1. This one looks like he's up here at 1, 2, 3, 4. So we're going to test those with trace. So I go trace 1, enter, and sure enough, there he is bouncing at 1. Then I go trace 4, enter, and sure enough, there he is crossing at 4. So that means I just found 3 of my answers. So I know since it had a double root that x equals 1 occurred twice. my circle got kind of out of hand there. Since it crossed through at 4, that is one of my answers. All right, here's the sneaky one. Even though it's really skinny back here, can you kind of tell how it probably should have touched the x-axis? It looks like if you really eyeball them back there, it was at -5. So I tested that out. Okay, so even though it didn't actually appear to be touching the x-axis, if I was suspicious and I tested x equals -5 with my trace, then there he was. He was actually hitting the x-axis. He bounced, obviously, because it was so skinny. So that means 2 of my answers are -5, which means that is how many answers now? 1, 2, 3, 4, 5. We're done. So we actually found all 5 of these answers straight off the calculator. Now, if you weren't sure about this or you forgot this trick or something, you could put those numbers that you did find in the boxes, 1 and then the 4, and then get down to the 3 numbers and run your quad, and then the quad would have given you these 2 right here. So you could have done that. But if you remember this trick, I got all of those answers straight off the graph in like 2 seconds. So try to use those tricks whenever you can. Save the time on the test. And use that trace to double check these, because even though it looked like these were on the 2, it was actually just off of the decimal of square root of 5. So always use that trace button. If it's at a fraction right here, remember to test the fractions with the denominator of the front number guy, okay? Thirds or fifths or sevenths. And that's only going to occur in the ones that have a front number guy, okay? And that's it. That's all of chapter 5. That was our grand finale. So let me know if you ever have questions, and have a great day.